Okay, so you was able to see I was able to set up a tank of water and move some objects through it. The one at the top, you can see it making the deformations on the top, and the one in the um, middle, you can see it moving. Now, if you actually look at things moving in a tank of water, totally submerged, you generally won't see things just moving like that. You know, moving the water, you're going to see it moving through the water. And so, at any rate, I did have what I consider some success, and I didn't do a splash, and that probably isn't necessary for the context of what we're trying to do here. But let's look at what I did. So here is the top level. We have the Alembic, which is going to be in essence aquarium, if you will. The Geo, which is our simulation. A camera. A RS light dome, so we have some lights. And we'll also have some materials and a rendering node. So let's look first at the Geo, because that's the heart of it. Let's bring this up and give it some more room. Okay, so I'm using the 19.5. I ran into issues. The issue I kept running into with the, for lack of a better phrase, the old way, or the using a .NET, is I just could not get it to really get through the simulation. It was just too slow. And I tried a bunch of things. My guess is maybe my scale was too big. However, when I switched to the SOP Flip in the to 19.5, it is relatively fast. So let's look at this here. So first thing you got is your flip container, and that is essentially where your liquid is held. Now, in my case, what I did is did I use a water? No, the water line isn't in here. And it has your size, your basic gravity, and there are other things. I pretty much left them for default. Let's get back to the collide and let's go to the flip solver. So the flip solver is what actually calculates all fluids. Now, this is interesting. My guess is this is because we have the thing moving. Let's go up for a second to the, we're on frame. Yeah, so it's kind of moving through, and my guess is if you go up to, you go here, well, that's not going to show it. Let's go back. Let's put this back here. And let's go up to the object. Oh, you can see. You can see the square right here. Okay, so we got our flip solver. Now this is where you can set the water line, and so it's going to go from the water line down to the bottom of your container. We have a fluid compress, and that's to compress the data, to have less data moving around. And, you know, it's packing things, and you can adjust some of these parameters that I have not looked into very much. But, so I left them pretty much at default. The fluid, the particle fluid, this is what gives us, I don't know why this is dark now, gives us our fluid surface, and you can see that here. Whoop, I'm trying to get this to, alright, let's go to, I think, oh my, I always, there we go. You can see it right here. Let's see if I can, let's see, which, No. Um, so, there you go. You can see that there. Okay. And then I put a material on it, which is a water material. And I merge it with these are the collision, the two boxes, the box on the top and the box in the middle. Since I haven't modeled any fish yet, they're kind of serving as proxies for these water tests. So that ended up actually working pretty well. It rendered relatively quickly. I actually, let's go up to the alembic, which is our, for lack of a better phrase, our aquarium. I pulled it in. This is what I pulled out from my cinema tests. And I did a transform because it's really, really huge. It came in really, really huge. So I wanted to do this transform. And then I added a material which is very similar to the water. It's the glass material. And so that's how I essentially constructed this. It was not that difficult. Now let's go look at the materials. They are under matte, and I created glass or water. Now I did a little trick because I couldn't remember the parameters. And now in Redshift, the new material is called standard material. The old one's called RS material. But standard material doesn't have presets. So since this is a test, wanted to make it simple. What I ended up doing is a little trick. So if you come in here and you say RS material, stick it here. Notice it has presets. So what you can do, what I did is I used I went to the preset and used those values and just stuck them in the standard material. Now this is all glass. So glass and water are very similar. The main difference is the IOR. So the index of refraction. And I also, for not for the glass, but for the water, I gave it a slight green tint so I can distinguish it. And when I'm looking at the water in my my aquarium that I am in the process of setting up, it's not quite ready for fish yet. It'll probably take they say about 3 to 4 weeks. There's a little slight green tint. So remember something with yeah, I did it in transmission. Can do it in reflection too. But when you are talking about these types of materials, your water, your glass, there's really no diffuse. You're focused on uh, on reflections and transmissions. So I just kind of copied those. And in the case of the water, there was a dispersion, and I essentially copied that, and that made it very easy. So I essentially recreated the preset in the new standard material. Um, so that's how I got my materials. A little bit of cheating, but for the purposes of what we're doing here, it worked. And I'm sure they're going to change. The other thing I want to do is select these rim things and give them a different material. I know how to do that in Cinema. I have to figure out the best way how to do this in Houdini. Maybe what I'll do is see if I can do it in Cinema and have the selections come in and see if that'll make them kind of separate. But at any rate, that's how the materials. Let me go back up. We'll go to out. This is where you have our redshift ROP, and this is the rendering node. I'm using ACES CG. So what happens is when you render using the open the render view, it gives you the right colors. You can see it's trying to render. Now it's going to be white because of the dome light. And where am I on this? Yeah, you can see it's starting to render. I don't know exactly what I'm going to get here, but you'll be able to see the cubes are going to be red, and I may have something set wrong on one of the other on the one of the other items in the network, the SOP network we did, and that may be making it that you can't see it here. Let's close this. Go back to object and go into the geo, and sure enough, it's set on the wrong thing. So now you can see your little squares, and now when we do our open render view and start rendering, you can see the squares coming in. And notice they're red. Let me show you. Now this is an ACES, okay? So you have to do a transition. Let me show you. This is DaVinci Resolve Studio. Move this out of the way for a second. All right. So you can see it's red here, but what did I have to do? Let's go to the color page. And I did this ACES transform node, and I simply took the input as ACES CG, which is how it's put out, and made the output Rec 709. And now you get the right colors. If you turn off this node, no, I don't want to delete node. Well, if you disable this node, it will go back to, these will be black and not the color that was selected. And again, that's a very simple material. So, let's go back to Houdini. Now, we also have the shelf tool. In this example here, I use the Flip tank, and this uses the Autodot network. And what it does, it starts with the Flip tank initial, and so you can merge in your collisions here, but the other thing it does is let's see which one it is, the Flip tank fluid. It imports the Flip tank in a SOP, and then it does the compressions, the particle surface, etc. And you can see, let's see, I'm already at 124 on this, and you can see it moving. So this will give you pretty much what we got. To me, it's a little bit more confusing because you have different parts. So this is merging in the flip tank fluid so that um, the render item there, this initial, I think this is where you can merge in your collisions, and I think this gives kind of this like wave thing on top. But to me, it's more confusing, but it probably gives you a little bit more, with having the wave stuff, which we don't need for this example. And you can see, I'm gonna do a render to render view, and you can see that it does. Let's make it re-render so that you know that it's actually. So it is actually rendering this fluid. Um, in my view, it's better to why not take advantage of the newer ways of doing things, where you're doing everything at the SOPs level, and certainly we know it's quick. So that is an example. They have a couple of these different things that that one can take advantage of. I'm not sure if they put the new stuff in a shelf tool yet, but the shelf tools basically are a good starting point. In this case, maybe not as much because we have newer tools that don't seem to have been incorporated into the shelf as yet, but that is an option that you have. I think I liked the simplicity of how it was how it was done in the actually the video that I used as the inspiration for this, which I'm going to put a link in. So let me see, make sure I didn't leave anything out that I want to talk about. No. So anyway, so to summarize, we had a fairly simple model to create this tank here, and then I just animated some blocks, and you can see they were interacting with it, particularly this one, because it's at the surface, you will see it. So that is going to be our basis. We don't need ocean waves. We may at some point have to worry about collisions where you're dropping something, but this gives us a really good start for what we're trying to do here. And it is relatively fast to simulate. It's not it's not a it's not the slow simulation. That was the problem when we were doing it in .NET. And I think this is one reason they moved to the SOPs level. They made these improvements is because DOPS level flip fluids were very slow. Even the small example that I used as the basis for that attempt, uh, he talked about it being slow. But I mean, in my case, and probably because of scale, I can't see anything else that would have caused it. If you have an idea, let me know. But I could not get it to literally could not get it to finish. I mean, it chug on for hours and then get to frame 50. Here I can go through an entire 240 frame animation and have things moving to the top of the water where it's very clear it's interacting with the water. Again, when you're underwater, it's less so. And if you look at pictures of videos of, let's say, fish swimming, which is ultimately what we want here, you don't see, when they're underwater, you don't see little water trails, or you may see some bubbles and things like that, but it's not going to look like if something's at the surface. So, at any rate, hopefully this has been helpful. Hopefully the example I went through is helpful, and we'll take it from there. So, speak to you next time. Take care.